Hello students, I am Professor NAVNEET KAUR, Associate Professor in Department of Electronics and Communication, Sagar Institute of Research and Technology, Bhopal. Today I will be taking lecture on subject Digital Communication. The topic of this lecture is Delta Modulation. Delta modulation is an analog to digital conversion technique which is used for transmission of voice information. Delta modulation is the simplest form of differential pulse code modulation, where the difference between successive samples are encoded into n-bit data streams. But in delta modulation, the transmitted data is reduced to 1-bit data stream. Only the change of the information is sent, that is, only increase or decrease of the signal amplitude from the previous sample is sent, whereas no change condition causes the modulated signal to remain at same 0 or 1 state. If the incoming sample is greater than the previous sample approximation, then in that case, bit 1 will be transmitted. Whereas when the incoming data stream is less than the previous sample approximation, that in that case, 0 bit will be transmitted. So only single bit will be transmitted, that is either 1 or 0 bit. In delta modulation, the oversampling technique is used in which the analog signal is sampled at a rate several times higher than the Nyquist rate. This is done to increase the correlation between the adjacent samples of the signal so that the difference between these adjacent samples can be encoded into a single bit. Now, here we can see the transmitter block diagram of the delta modulation system. Now, first we can see the sampled input, which is the sampled version of the message signal. Now, this sampled input is compared with the previous sample approximation. The difference between these two samples is denoted as the error signal EKTS. Now, this error signal is given to the 1-bit quantizer. Now, this 1-bit quantizer will convert this error signal into signal BKTS. When sampled input is greater than the previous sample approximation, that in that case BKTS will be given by plus delta. Whereas when sampled input will be less than the previous sample approximation, so EKTS will be negative in that case. So 1-bit quantizer output will give output as minus delta. In case when plus delta is generated, the output will be encoded as bit 1 and will be transmitted. Whereas when BKTS is minus delta, then output will be encoded as bit 0 and will be transmitted as bit 0. Now, when plus delta or minus delta is generated, this amount will be added to the previous sample approximation to generate present sample approximation, which is UKTS. This means that if the sample approximation is lagging behind the sampled input, in that case, it will be increased by that amount, which is plus delta, and will try to reach the amplitude of the sampled input, so that the difference between the present sample and the previous sample approximation can be reduced, and the difference between these two samples will be encoded into a single bit. Now, when present sample approximation UKTS is generated, which is given by UK minus 1 TS plus minus delta, it will be given to the delay unit. The delay unit will delay the amount UKTS by 1 time symbol period, which is TS. Now, by that time, next sample will appear and the previous sample approximation will be compared with the present sampled input, and the cycle will continue. The block diagram, which is given in the lower section of this transmitter, is known as accumulator, which is used to generate the previous sample approximation. Now here we can see some set of equations which are given in the transmitter block diagram. ENTS is given by the XNTS minus X cap NTS as shown in the block diagram. XNTS is the present sampled input, and X cap NTS is the previous sample approximation. UN minus 1 TS is the same as X cap NTS, which is last sample approximation. Now, as I told you that BNTS is given by plus or minus delta. So it can be represented as delta signum ENTS. That means signum, we know that it can take either value +1 or -1. So BNTS will have value either plus delta or minus delta. Plus delta value will be generated when XNTS is greater than equal to X cap NTS, whereas minus delta value will be generated when XNTS will be less than X cap NTS. So when BNTS is plus delta, binary 1 is transmitted, and when BNTS is minus delta, binary 0 will be transmitted. Now, somewhere in the accumulator will add this quantizer output plus minus delta with the previous sample approximation to generate present sample approximation. So UNTS will be given by UN minus 1 TS plus BNTS. Now, depending on the size of ENTS, 1-bit quantizer produces plus delta or minus delta, and according to that, binary 1 will be transmitted for plus delta and binary 0 will be transmitted for minus delta. Now, here we can see some of the waveforms for delta modulation system. This is the clock signal. The time period of this clock signal is TS, which is sampling interval. Now, this is the message signal, which is being transmitted. And this is the approximation of the staircase waveform. When the staircase waveform is less than the message signal, in that case, the difference will be positive and 1-bit quantizer will produce plus delta. So the previous sample approximation will be added by plus delta and will be increased in amplitude. Now it will be delayed by amount TS. It will maintain this amplitude. Now after TS, again, previous sample approximation of the staircase waveform will be compared with the sample of the message signal. Now again we can see that previous sample approximation is less than the message signal. So in that case, the output of 1-bit quantizer will be plus delta, which will be added to the previous sample approximation. So it will again rise in amplitude. Now it will be delayed for 1 period TS. Now again it will be compared with the present sample of the message signal. Now here the previous sample approximation of the staircase waveform is greater than the present sample of the message signal. So the output of the 1-bit quantizer will be minus delta. So this minus delta will be added to the previous sample approximation. So it will show reduction in the amplitude. Now it will be again delayed for 1 TS, and in this way the staircase waveform will be generated. Now this staircase waveform will try to follow this message signal. Now here we can see that whenever the staircase waveform is added by plus delta, in that case bit 1 is transmitted, whereas when the output of 1-bit quantizer is minus delta, in this case, in that case the bit 0 will be transmitted. Now this is delta modulation receiver. Here we can see the accumulator section. The accumulator generates the staircase approximated signal output, and it is delayed by 1 sampling period TS. Then it is added to the input signal. If input is binary 1, then it will add plus delta step to the previous output. And if input is binary 0, then it will be subtracted by delta amount from the delayed signal. The low pass filter has the cutoff frequency equal to the highest frequency in the message signal. This filter smoothens the staircase signal to reconstruct the message signal xt. Now, coming to the limitations of the delta modulation system. There are two major drawbacks in delta modulation. First is slope overload distortion. In slope overload distortion, the rate of rise of input signal is so high that the staircase signal cannot approximate it. That is, the step size becomes too small for staircase signal to follow the steep segment of xt. Hence, there is a large error between the staircase signal and the original input signal. This error is known as slope overload distortion. To reduce this distortion, the step size must be increased whenever the slope of the signal is high, so that there is a small difference between the signal and the staircase approximated signal. Now, coming to the second limitation, which is granular noise. Granular noise occurs when the step size is too large compared to small variations in the input signal. This means that for very small variations in the input signal, the staircase signal is changed by a large amount because of the larger step size. When the input signal is almost flat, the staircase signal keeps on adding or subtracting by plus minus delta around the signal. So there will be always difference between the amplitude of the staircase signal and the message signal. This error between the input and approximated signal is called granular noise. To solve this problem, the step size should be made smaller. Now, here we can see in this figure the effect of slope overload distortion and the granular noise. Slope overload distortion occurs in this region when the slope of the message signal is steep. So, the staircase signal, in spite of the fact that it is increasing by amount delta every time, but it is not able to pick up the message signal. This difference is known as slope overload distortion. Now, this effect is granular noise, where the message signal is almost constant. But since the staircase signal is higher than the message signal, it will be reduced by delta. Now, it will be delayed for amount ts. Now, since it is smaller than the message signal, it will be increased by plus delta. So in this case, there will be always a difference between the message signal and the staircase signal, which will give rise to the error known as granular noise. Now, applications of delta modulation system. Voice transmission system such as television, telephone and radio communication highly prefer delta modulation technique. Delta modulation is most useful in systems where timely data delivery at the receiver is important than the data quality. This modulation scheme is applied to ECG waveform for database reduction and real-time signal processing. Data modulation is applied in television systems. For analog to PCM encoding, this data modulation method is the appropriate method. Now, this is all for today's lecture. Thank you.